All right, here we go. We have lesson 1.3. We're going to be solving equations with variables on both sides. So the key idea, basically, when you solve equations with variables on both sides, you want to collect the variable terms to one side, the constant terms to the other. So it's very important to keep both sides of the equation clear. So here's an example from the textbook. It says solve 15 minus 2x is equal to negative 7x. Obviously write the equation. We want to go ahead, and this is where it becomes crucial to pay attention to both sides of the equal sign. So maybe possibly drawing that line so that you're making sure you're doing the same thing to both sides. There's an x here and an x here. There's no other number. So it's just as easy, and probably the easiest step is to just add the 2x to both sides, making sure that this is that additive inverse so that it cancels out. And then you just do the math. This is integer math. Unlike signs, we're going to subtract, keep the sign of the highest absolute value. So negative 5x is equal to 15. Then we'll divide both sides by negative 5, and we get negative 3. And you can check it out and substitute it in to make sure that it works. Okay. All right. So this is what you're going to be doing. It says solve the equation, check your solution if possible. So now that we're putting variables on both sides, this is where you're going to have possibly one solution. That's what we've had so far, right? An example of this would be x is equal to 2, right? Or some number. Sometimes you have no solution. And when you get to the end of your equation and you get something that says, like, I don't know, maybe 2 is equal to 4. Is 2 equal to 4? No. That's not true, ever. No solution for that equation. Or possibly infinitely many solutions, because you'll get something like 2 equals 2. And these are just examples, but is 2 equal to 2? Yes, always 2 is equal to 2, which means no matter what number you substitute in for the variable, it will be true in all situations. And then you would say infinitely many solutions. So we'll start over here with number 1, identifying the equal sign is here. We have a variable of x on this side, a variable term, and a constant term. So it'd be just as easy to get rid of this variable term from the right-hand side. It's a positive, so we want to use the additive inverse, which is negative, or subtract it on both sides. Okay, so 2 minus 2 is 0. Always want to check that out. Negative 3 plus negative 2 is going to be negative 5x. Some integer math right there. Bring down the 19. With the variable, we're undoing multiplication with division. Divide both sides by negative 5. Okay, that cancels that. So x is equal to this negative 19 fifths. And if you put that into your calculator, it is equal to a negative 3.8. And that's okay if you want to change it to a decimal. I'm fine with that. Look at number 2. Let's change colors just for fun. We have a distributed property, so we want to get rid of the parentheses. So we'll take 4, and then 4 times 1, and 4 times a negative p, which is negative 4p, is equal to a negative 4p plus 4. So we have our, all right, so let's go ahead and bring the variable term here, and then we can maybe bring the constant to the right, or however you want to do this. Since that's negative, we're going to add 4p to both sides. Oh, and look, that's also negative. So negative 4 plus 4 is 0. Negative 4 plus 4 is 0. We end up with 4 is equal to 4, and that is always true. So we have an infinitely many solutions. Okay. In this situation, we could check our work and know that we got it right. In this situation, you probably don't want to, but just double check. At this point, when we rewrote it, we could see that this is the negative term, that's the negative term, this is the positive term, that's the positive term. It's the exact same thing on both sides. That's how we know it's going to be infinitely many solutions. All right, we will watch this video in class the next time we talk about this. or tomorrow. All right, let's look at this. So we have a situation going on. This is an example from your book. The circles are identical. What is the area of each circle? So they're giving you the radius here and the diameter here. So we kind of need to be using the radius here. So half of 4x is 2x. That's where this 2x comes from, because we want to be using the radius of the purple circle, which is 2x. So we can say that the radius of the green is, and since they are told that they're identical, right? They're equal to each other, is equal to the radius of the purple, or 2x. So again, we want to subtract x from both sides to move the variable term to the right. We'll get 2 is equal to x because 2 minus 1 is 1. Now, what that's given us is the x. So we could put it here, right? 2 plus 2 is 4. That means that the radius is 4. Radius is 4. So we wanted to know what is the area of the circle, and we need to know a little bit about an area formula, pi r squared. So pi times this 4 squared, okay? They did that for us here, and they said 16 pi, and without multiplying in pi, we can just, in terms of pi or whatever, give us the answer. So in this example, that was example 3 in your book, what if we changed this one here to 3x, okay? So that means that half of 3x, because this is the diameter, that makes the radius of the purple circle now equal to 1.5x. So the same equation everywhere. X plus 2 is equal to 1.5x. We'll still go ahead and subtract x. So we'll get, and that's there. So 2 is equal to 0.5x. I'll just go ahead and keep it in the decimal form. Then we're going to divide both sides by this 0.5. Now, you want to put this in your calculator, right? Because when you're dividing by a fraction or a decimal like this, you know that the number is going to get bigger. And so x in this case is equal to 4. So if x is equal to 4 right here, we could say like right here, 4 plus 2 is 6, or we could do 1.5 times 4. So we know that the radius is equal to 1.5 times 4, or 6. So if our radius is 6, the area, which is pi r squared, oops, that's what the area equals, would be equal to pi and then 6 squared, or simply 36 pi, if we went ahead and simplified that down and left it in terms of pi. So if you have any questions about that, you can definitely put that in the very last place on the Edpuzzle. So with the vocabulary in check, same thing, go ahead and pick one, either 1 or 2. Please make sure that you're writing in enough detail and not just simply putting just a random answer, but letting, give me some explanation, some typing in something. And then if you have any questions, give me that as well. And that concludes our video for today. See you in class tomorrow.